Welcome and thank you for joining. In this example, we're taking a look at subtraction of two rational expressions where the denominators are in trinomial form. So we follow basically the same steps. Step number one would be to factor the denominators. So in this case, we have 4 in the numerator, and denominator, which is in trinomial form, will factor into x plus 3, x plus 2. Remember that the product of these two numbers have to be 6, and then the sum has to be 5. Next, we are factoring the denominator in the next rational expression. So in this case, we're going to start with x as the first term in each binomial factor, and that's because that's where we get x squared from. And now we have to think of two numbers that multiply to negative 12. Think about it. There will be two numbers of opposite signs because the product is negative and the sum has to be negative 1. So the two numbers must be close to each other. So the two factors of 12 close to each other are 4 and 3. And 4 will be the negative one because the sum is a negative. So next we'll have to find the lowest common denominator. So when you look at the lowest common denominator, obviously we have to inspect the factors in each rational term. So here we have a factor of x plus 3 and x plus 2. So I'm going to list them down here as x plus 3 and then x plus 2. Now the factors of the second denominator are x minus 4. So x minus 4 is a new factor. We didn't see this in the previous denominator, so we're going to give it a special spot. And x plus 3 is common to the x plus 3 in the first one, which means that we have to list it right underneath the x plus 3 from the first denominator. And now we're going to say that the lowest common denominator, remember how we did this in the previous examples, we're going to bring x plus 3 down. We only need to count it once because it repeats. And then we're going to bring the x plus 2 down. And lastly, we have x minus 4. And this would be the lowest common denominator. And while we're at it, we're going to state the restrictions. So remember that the restrictions are that neither factor in the denominator can equal 0 because then the product of the three factors will be entirely equal to 0, which makes the expression undefined. So we're going to say that x plus 3 is different than 0, x plus 2 has to be different than 0, and x minus 4 also has to be different than 0. So x is different than negative 3, different than negative 2, and different than 4. So now we're going to go back to our expression and we'll make sure that the denominators become the same as the lowest common denominator. So in the first expression here, you see that you have x plus 3 and x plus 2, and we're missing x minus 4, which means that we need to multiply by x minus 4 both numerator and denominator, which ensures that we're basically multiply the entire expression by x minus 4 over x minus 4, which is equal to 1. So the value of the expression has not changed. That's the way it looks. So next, we have to look at this denominator. We have x minus 4, we have x plus 3, and we're missing x plus 2. So that means that this denominator will need an x plus 2, factor of x plus 2 to become same as the lowest common. So we'll do the same to the numerator. So now that we have all the denominators the same, we're going to bring or subtract the two rational expressions. So now we're allowed to subtract them. And I'm going to start off with, I don't know why this is coming red. All right, so x minus 4, x plus 3, x plus 2. That's the lowest common denominator. And in the numerator, we have 4 times x minus 4. So feel free to start expanding in here, which means we'll have 4x minus 4 times negative 4, negative 16. And here we have 5 times x plus 2. Now remember, when you have a minus before the fraction, it means that every term in the numerator will have a minus, which means that we can give the minus to 5, so negative 5 times x, negative 5 times 2. So that would be negative 5x, negative 10. Now, one last step, we need to simplify the numerator. So for this, we have to collect like terms. So 4 minus 5x will give negative 1x. Negative 16 minus 10 will give negative 26. And in the denominator, we have x minus 4, x plus 3, x plus 2. And the restrictions were x different than negative 3, different than negative 2, and different than 4. And that would be the answer to this question. Now, in case you're wondering where is the last step, remember that one of the steps in simplifying rational expressions is to ensure that we're writing the final answer in the most simplified and factored form. In this case, we can factor out negative 1 or leave it in expanded form because it's easy to see that there are no common factors of numerator with a denominator that can simplify. So the next example is for you to try. So I'm going to continue working on it, but obviously you can try this on your own. So pause the video, work on your own, and then check the answer at the end. So similar to what we did before, we're going to rewrite this expression with factored denominators, which means that the first denominator will be x minus 1, x minus 1. Notice this is a perfect square trinomial. And the way I know it is because the last and the first term are perfect square terms, and the middle term would be 2 times this number that has been squared times this number that has been squared. And that means that since it fits into the formula, it's a perfect square. You can always, since we're talking about it, you can always factor a perfect square trinomial like we normally do any trinomial because they are any trinomials anyway, so as a general trinomial. And now here we have x minus 1 in the numerator. And the next fraction, or rational expression, we have x minus 2, x plus 2. I hope you recognize in here the difference of squares. So the difference of squares formula states that a squared minus b squared is a plus b, a minus b. And this would be the factored form for x squared minus 2 squared. So x minus 2, x plus 2. And notice that here we have x plus 2. Now, this example is kind of unique in a way because it brings to our attention the fact that we can sometimes simplify a factor in the denominator before we combine fractions. So if you're wondering whether or not we're allowed to or whether or not we should, then the answer is yes. So before we simplify, though, we want to make sure that we are stating all the restrictions. So we have to be flexible with the restrictions. We have to understand that we cannot lose restrictions, so which means we have to state them before any simplification of a factor in the denominator takes place. And we're going to say that x minus 1 has to be different than 0, so x different than 1. Obviously, this other factor is the same, so we don't have to write the same thing twice. X minus 2 is different than 0, so x has to be different than 2. And x plus 2 is different than 0, so x has to be different than negative 2. So now that we've stated the restrictions, we can go ahead and simplify the common binomials with confidence, and that will make the rational expression subtraction a lot easier. So in the numerator, now we have 1. Denominator has just x minus 1, and then minus 1 over x plus 2. So as you can see here, we have the lowest common denominator of x minus 1, x plus 2. So when we have two rational expressions that have completely different denominators, the lowest common is very easy to find as the product of the binomials that you have in here because they're also factors of the denominator. So we're going to try to make this x plus 1 same as the lowest common denominator. So we'll multiply it by x plus 2, and we'll have to do the same thing to the numerator. And we'll continue on with the next rational term, which is 1 over x plus 2. We'll multiply this by, guess what, x minus 1. And now we will bring both rational terms under the same rational expression. So we have x minus 1, x plus 2 the denominator, and numerator is x plus 2 minus. Be very careful when we are subtracting rational expressions, and when we have especially more than one term, like in this case we have 1 times x minus 1, it is very important that we keep that x minus 1 in brackets. So you either keep it in brackets, or you be good at remembering that this minus will affect the signs of it. So when you subtract x, subtract -1. So I'm going to show the long way here, obviously, because we don't want to get lost in the process. We want everyone to understand this. But what I'm trying to emphasize is the fact that we can take that shortcut in there. So x minus 1 and x plus 2. And x minus x equals no x. 2 plus 1 is 3, divided by x minus 1, and then x plus 2. And remember to say the restrictions at the end. We have x different than 1, different than 2, and different than -2.